I'm Sam Hill-Cristol. I'm Director of Strategy for the Mobility House North America. Welcome to our V2G ACT Expo tour. We've been doing these tours for the past couple years, and in the past we've focused on interoperable charging and what that means. But this year we wanted to switch it up a little bit and try to give everyone a little insight into the state of the V2G industry. We think we're sort of at a tipping point where we're moving from V2G pilots into more commercial deployments. Someone probably said that 3 years ago, but we actually think we're there now. So our goal with this tour is to take you around the floor, guide you to the different partners that we're working with, vehicle OEMs, charger OEMs, utilities, kind of give you a sense of the state of the art. Our first speaker is going to be Russell Vare from the Mobility House. He's our VP of Vehicle Grid Integration, overseeing all of our V2G work. So I'll pass it to him to start.
All right, thanks. Morning, everyone. Appreciate you taking the time to come visit. If you're not familiar with Mobility House, just briefly, we're a charge management software company operating a couple thousand fleets worldwide. In the US, we've been doing a lot of transit agencies, school districts, and we've had this charge pilot system that sits on a local controller, which can manage energy at the site. And we've now expanded into a new product called Cascade, which is our EV aggregation platform, which can add new value to these fleets, especially in terms of load flexibility, being able to do new energy services, and one of those being vehicle to grid, which we wanted to give you an update on where we're at. So we've had some good, it's early, as Sam said, early market, early progress, but we had our first V2G school bus site interconnected and operating last summer. In Fremont Unified School District, we just expanded that to another few charging stations a couple months ago. We had our first residential V2G interconnection in San Diego Gas and Electric with a wall box and a Kia EV9 system. We have projects underway in Massachusetts, Colorado, New York, others in California. So we're really seeing, I think, a couple of things that are starting to shift, as Sam said, is one is that interoperability is becoming available now that the standards have been kind of published and some of these partners are building to those standards. So that focus of Mobility House on interoperability has always been there for unidirectional charging, and now we've seen a shift the last couple years of products coming to market that enable that. So what we wanted to do on this tour is to help you understand what some of those products are that are out there, see who those experts are so you can come find those people. So hopefully the goal is you see where the market is, who to talk to, who the company, some of the players are that can make this possible, because we need all of these aspects, the charger, the installer, the software player like us, and then the utility that can bring value to doing bidirectional charging. So with that, I'll kick it off with Rudy from PG&E.
Thank you. Good morning. Thanks for asking me to speak, the opportunity. It's reminding me of one of those silent raves where everybody's listening to music, dancing somewhat differently perhaps, I guess that's sort of the challenge here, is that, with V2G is getting us to do it all together. So I'm Rudy Hall, Product Manager, Vehicle Grid Integration at Pacific Gas and Electric. I lead our commercial V2G pilot, and which has included this Fremont site that we're just talking about. And we have a total of right now about 80 chargers paired with buses online. 6 of them are with the Fremont site. 3 more will come in later this year, and then 3 more with another site also in the Bay Area. And we're really trying to remove the barriers to being able to scale this technology. And it's definitely been a challenge. It's been very slow coming. We've been working on this. I think the first time I talked about V2G, someone reminded me earlier, was in 2010. So I obviously have a lot more patience than I knew that I had, which is great. Starting to finally slowly pay off. And what we're really working on now is incentivization to make sure that there's an opportunity to get value from doing it. And the biggest one is we have an emergency load response program, which incentivizes $2 a kilowatt hour for people who export to the grid. Actually, if you normally charge during that time and then you export, you could get $4 a kilowatt hour for 30 hours a year. So that's really nice. If you could do that every day, then we'd all be retired by now. But the challenge is to do it depending on where we are in our distribution system. So we're still learning. We're using an hourly flexible pricing, which is still a work in process, and hope to be able to see that scale in the years to come. I think there's a lot of potential for being able to move energy from the time when we have abundance with solar maximum. If we're still allowed to build solar in California and the US, well, it's another topic, but wind, solar. But being able to move that later in the day when we really need it, and as we electrify all of our homes and change needs. So thanks for coming.
Awesome, thanks, Rudy. I think one thing also to highlight about our work with PG&E at the Fremont project, in addition to the ELRP program, which is a demand response type program that can compensate export, we're also rolling out optimization on what's called the HFP rate, which is an hourly rate that also can include export. And so that's sort of some value stacking, right, that's happening. And I think we're starting to see utilities just lay out sort of a set of rules for compensation. We also see that in New York with the VDER tariff, which sort of says like, hey, if you can export at these times, this is what you'll make. And then that puts the onus on the technology provider, like us, to make an argument to the customer, hey, here's why you should do this. And it's great to have specific V2G programs, but having technology neutral programs that have a certain set of compensation rules is almost just as good, because then it's up to us to find the opportunities, and then that creates an industry around that. Our next speaker is with InCharge Energy, so one of our partners when it comes to the actual bidirectional hardware. Nicholas is the CTO. Take it away.
Thank you very much. Hello, everybody. My name is Nicholas Range. I'm the CTO at InCharge Energy. And together with the Mobility House, we are trying to reduce the hurdles that are bringing us towards bidirectional charging and actually reaping the benefits that Rudy and Russell here prior to me were pointing out. When it comes to the challenges and where we at InCharge are specifically focusing on is about the interoperability aspects of making sure that the charger talks properly to the vehicle. Yeah, the landscape at this point when it comes to the charging communication, meaning EVSE and EV, is, as I usually call it, a very colorful bouquet of different solutions that are so far out there. Yeah, so if it is our friends at Heliox, our own chargers that we are building, we or the colleagues from Tellus, we need to make sure that we are providing here our customers a complete interoperable solution. Yeah, so that the school bus operators, for example, can actually change the buses depending on where they need to charge on their parking lot. So at this point we have different flavors of 15.11.8 -2 implementations, -20 with or without TLS is in demand, and hopefully we can finally settle on something. We have DIN 71-1 flavors in there, where we're literally just putting a minus in front of the current requests in order to initiate the discharging sessions. So that is one big piece, so the vehicle to charger communication is one big piece that we need to try to solve for, and need to make it easy for the bus operators to actually utilize that solution properly. The next big thing is then further going upstream towards the utilities is then the charger to backend communication. OSPP 1.6, 2.01 do not provide any standardized bidirectional messages. So all of this is also then here a hodgepodge of solutions. And I do actually appreciate here the leadership of the Mobility House, which is maybe bringing all of us together and can then finally set at some point on 2.1 implementations. Right now we are working on 2.01 plus 2.1 messages. So there are a lot of efforts that we are all putting in to make this somehow more and more seamless between all of us. The next piece that I'm very excited about, what we're currently working on with Russell Var and his team, is the integration of Cascade into InControl. So that is where we are trying to enable then also the utilities to send the proper discharging or charging schedules to a backend that then can bring it further downstream towards the charger level. And that is going to be actually enabling very nicely the communication from the utility over the different DERMs and virtual power plant providers, down then to the charger management system, down then to the EVSE, down then to the vehicle. And controlling that chain and making that actually seamless is fairly difficult because again, there are no real standards yet properly implemented, but I'm very glad to see and to hear also from all of our friends in the industry that we are striving here towards the goal of, let's call it, complete interoperability. So thank you very much for having me, guys. It is actually very, very cool to work on those type of projects. And I usually tell my team that these are very sexy problems to be solved here. So I'm very happy about that. Thank you, Sam.
Thank you, Nicholas. Before we go to our next stop, I wanted to plug our new bidirectional charger guide. We just put this out, trying to sort of provide a written resource for a survey of the different bidirectional chargers that are on the market, specifically looking at school buses. That's sort of the most common fleet segment that we're seeing these projects go live. So we have a booth copy, so come check it out, talk to us about the different options. Our next stop is 10 feet away to the ABM booth. I'm happy to introduce Joshua Goldman, Senior Director of Sales for ABM. They're a great partner of ours, specializing in delivering turnkey EV charging projects, also incorporating DERs. They're one of the firms that we really trust to handle the actual installation of these super complex sites.
Thank you, Sam. Can you all hear me okay? Can I see a show of hands? Who's heard of ABM before? All right, you might think of us as facility maintenance, facility management company. You might think of us as janitorial services, parking lot operators. We actually have a whole technical services and solutions division that are kind of the engineering nerds of the company that help do design, build, operation, and maintenance services for all types of commercial properties. In the case of our group, with e-mobility and RavenVolt, we do EV charging and we do microgrids, all within as a self-contained EPC that can also continue to operate and maintain that equipment for the life cycle of that customer, both private and public fleets around the country. Even into Canada. And we are here because we have a partnership with Mobility House and a very, very large school district in California that is receiving a couple hundred electrified school buses that are vehicle to grid capable. And they're electrifying a whole depot that'll have almost 200 level 2 and level 3 chargers there that'll have software from Mobility House and 66 vehicle to grid enabled DC fast chargers with Tellus Power that allow the battery power from those buses be able to go as part of the microgrid solution, along with a megawatt of solar and a megawatt of battery and temporary genset hookup capability to not only power the depot, but also power LA's grid through LA Department of Water and Power. And so this is one of the largest vehicle to grid applications in the country. Hopefully we deliver it in time for the Olympics in a couple of years. And that's just one example of the many kind of projects we're doing here with ABM RavenVolt that kind of take these complex solutions of charging and microgrids and all sorts of various loads from trucks and buses and cars and put them together in a single solution from a turnkey provider like us. So thank you all for coming here. We're around for the rest of the show, booth 3511. We have lots of giveaways we'd love for you to enjoy and talk to us more about the kind of things we can do for your customers.
Sweet. Thanks, Joshua. Our next stop is right over here. We're going to the Heliox booth to hear about another bidirectional charger that's on the market. Our next speaker is Carter Palmy, who's a sales engineer at Heliox. We're very excited for their bidirectional charger to come to market. For a long time, we had specialists making bidirectional chargers, which was great because there was product, but we were waiting for a company that we knew was going to be around, that had backing, that had O&M and all of that to start rolling out an offering, and I think Heliox Siemens is a great example of that. So without further ado.
Yeah, thanks so much, Sam. Yeah, Sam, I couldn't have said it better myself. I think I'll just hand the mic back to you. But hey, everybody, my name's Carter Palmy. I am the sales engineer with Heliox, a Siemens Business. For those of you familiar with Heliox or Siemens e-mobility team, we were purchased by Siemens at the end of 2023 and now operate under one roof in Heliox, a Siemens Business. Our 44 kilowatt bidirectional charger, it's the unit you see here. For anybody familiar with our 60 kilowatt or 30 kilowatt or our dual port 60, you'll notice that the enclosure is very similar. It is the exact same enclosure, we just have different internals to make this a bidirectional unit. So this is a unit that was developed here in North America by our R&D team based in Atlanta, Georgia. That's where we are headquartered. And with this unit, like Sam was saying, it is a UL listed ISO 15118-20 compliant bidirectional charger. It is at 44 kilowatts, which is, it sounds silly, but it was the drives that were available at the time during design. So we do plan eventually to replace those drives and make it a 60 kilowatt bidirectional unit, but it is a very easy drop-in replacement for the 60 versus the 44. Just to kind of do a quick teaser on the rest of our lineup, we also just released, as of a couple hours ago, our Flex Pro unit. That's the unit you see on the over my left shoulder here. That unit is a 480 kilowatt charger, and it is fully dynamic charging up to 6 outlets in units of 80 kilowatts. But again, to get back to the bidirectional side of things, it is very important when we're looking at these bidirectional products and projects to work as partners with the rest of the industry. We need to work as a partner when it comes to the charge management side of that equation, when it comes to the vehicle OEM side of that equation, because there is a lot more communication going back and forth, especially when we look at taking that energy and putting it back into the grid in a virtual power plant scenario. We are then bringing in the utility and having those utility interconnections done as well. So it's very important that we all work as an industry very closely to ensure that when these projects are deployed, they are operating in a smooth fashion for that client, because at the end of the day, for bidirectional, most of the traffic we have for this unit is in the school bus market, and those operators need to pick up those kids and move them to home and to school every day. So it's very important that we all work together and make sure that it's a smooth process from installation to commissioning to day-to-day operations. We will be here the rest of the show. Please come by after the tour if you do have any questions on the 44 or any other unit you see in this booth, and look forward to seeing you all around the show. Thank you so much.
Thanks, Carter. Okay, our next speaker is Saleh, who's the CTO of Exos. We haven't yet deployed a project with Exos, but we have a couple joint customers, and we're excited to collaborate with them on those projects.
Hey everyone, thanks for having me. My name is Saleh Haidari. I'm the CTO at Exos. Exos builds electric commercial vehicles, and we also make energy products, and we sell our powertrains to different companies like Bluebird and some other customers to electrify their fleets. Late last year, we had a request from one of our customers, Bluebird, to do bidirectional charging for our system, and because most of the vehicles we build, they actually have at least 140 kilowatt hour battery on them, so they're a great asset for grid balancing and participating in different programs. So we introduced ISO 15118-20, the latest version, and we had to do some hardware modification and software changes, but we tested with a few different vendors, and it's in production as of April. They actually already started producing the product, and it's a school bus application. It's a great application because you only use the bus for a couple of times a day, in the morning and afternoon, and you have downtime. You can do peak shaving, you can do grid balancing and participate in different programs. And also with the school bus, you get 3 months off during the summer, which makes it a great application. We also are going to bring it to our other products like the hub and also the other trucks we're working on. Most of our application on the truck side is last mile delivery and linen and some other applications. They're not as good as school bus, but still you get a lot of downtime at night, so you can participate in different programs and get the most out of your systems. We also have the energy products. We call this charging hub. This has batteries on board, so you can charge it from grid through a 480 3-phase or a DC charger and AC charger. We are going to bring the bidirectional charging to this platform too, to be able to use your battery not just for charging your vehicles, but peak shaving and everything else that you do with the bidirectional power.
One point we're excited about Exos is that cross sort of segment applicability. So talking about commercial vehicles and last mile delivery. I mean, to date we've really seen market ready bidirectional vehicles in the school bus space and like the residential vehicle space, and not a lot of other places. We had a project in Massachusetts where we were trying to deploy 100 chargers, and we really couldn't find the municipality vehicle besides like a Ford F-150 that had the capability. So we're excited to see that bidirectional capability start to actually spread outside of the school bus space. Thank you so much. Sure. I think our next stop is Thomas Built Buses. For our next speaker, we have Mark Childers, Powertrain and Technology Sales Manager for Daimler and Thomas Built Buses. We, at our V2G project in Fremont, which we mentioned earlier, we are doing discharge and have completed discharge events using a Tellus charger and an existing Thomas Built bus that the customer had before the project. So we were able to prove that interoperability in the field. So excited to have Thomas Built as our partner.
Thank you, Sam, and good afternoon or good morning. My name is Mark Childers with Thomas. Happy to have you stop by our booth. What you see behind me here, just real quick, is our newest addition to our electric fleet, which is our Type D Watson bus. It is 246 kilowatts of battery pack, similar to what we have on our Type C, which is a conventional in the front. Both buses are V2G capable, so we build our buses so that we can discharge in those scenarios like Sam mentioned in Fremont, California, where we are discharging the vehicle. Currently today, from a discharge standpoint on V2G side, we have several projects in addition to Fremont where we have discharged over 100 megawatts of energy through our vehicles in various locations. And a lot of that depends on the relationship that the school district has with the utility company. So it's very important that when school districts enter into these relationships with the utilities, that planning happens well in advance of V2G decisions to go do the V2G. And so with partners like Mobility House and others that we are, we go through the process, set up those programs where we can discharge that energy with their support. It's a very financially beneficial to the school district in terms of generating some revenue for them, but also it's giving back to the community and that energy going back to the grid to help those utilities support the grid and kind of level off grids where the peak demands are. So we are very excited with what the V2G landscape looks like in the future. I think it will continue to grow as more school districts get used to and utilities come on board with either time of use rates, those types of things. So as utilities start to bring that on board, we're going to see more of the school bus opportunity to grow vehicle to grid, or in some cases, depending on how they want to set it up, it could be vehicle to building if that's the case too. So like I said, a lot of it depends on how it's set up with the utility, whether or not this vehicle is sitting here and it is waiting for somebody to tell it what to do, whether it's going to tell it to charge or it's going to tell it to discharge. And that's kind of what we do with our vehicles in our design at Thomas. So we've designed it to do that. So Sam, awesome. Good? Yeah, all good. Thanks for stopping by our booth. Have a great show. Enjoyed it.
Okay, welcome to our last stop at Tellus. Sri, who's Senior VP at Tellus, will be speaking about their products. We've done a good amount of bidirectional work with Tellus. We work with them on our Fremont project that we mentioned. We're also deploying a project in the Bronx in New York City, which will have 15 Tellus 20 kilowatt V2G chargers. And I've asked Sri to talk specifically about the process of what it really takes to test with vehicles, because I think you've heard a lot about the fact that the standards are developing and there's different versions and how does that all work. But he's actually on the front lines doing that testing with OEMs and proving out that discharge.
Thanks, Sam. Thanks for the quick introduction. I'll talk a little bit about the company myself and go into the details of the products in a bit. I'm Shrikant in full name. I'm from Tellus Power. We manufacture EV charging stations. We have quite a bit of products here we are demonstrating. We have this, what you're seeing is a bidirectional charger, 60 kilowatts. We have a 20 kilowatts bidirectional system there. We have a mobile charging unit. And we have just recently launched a distributed charging system called Nexus Charger, which starts at 600 kilowatts, goes up to all the way up to 1.2 megawatts. It can have different connectors, CCS, NACS, and MCS. Predominantly, the focus has been on the MCS at this point of time for us, and we're able to do that with 1.2 megawatts distributed charging system. Coming back to the topic, the bidirectional charging system, what we have. We've been doing the bidirectional charging system for about 3 years now at different capacities. We have 3 different variants at this point of time. One is 20 kilowatts, 30 or 40 kilowatts, and then 60 kilowatts. We have done quite a bit of interoperability testing with various OEMs out there in the market. We have done utility integrations, utility certifications, Let's say we start at UL 1741SB certification for utility in inverter certification for interconnection, and then we have a 9741 UL as well on this one as a safety standard regulation for bidirectional. We are OCPP compliant, 1.6 with extensions, and 2.1 as a native support for bidirectional. So that's the one which, we've done extensive work with Mobility House with a charge pilot, and we've been successfully using that at one of their sites in Fremont, working out really well for the last few months there. Coming to the integration, what we have done with various OEMs. So it's not simple, it's not straightforward. It's a new concept, new protocols and everything. We have developed on the bidirectional charging station, we have implemented two different variants of bidirectional protocols. One is 15118 Part 20 draft stage, which was there from quite a bit there. We have done it in 2023. And then soon after we adopted the published version of Dash 20 release version. We have quite a few of integrations with both the standards at this point of time. Let's say we started with Lion, BYDs, then we have done with International, Thomas Built, Bluebird, different folks out there. So one of the things what has been a challenge in this process of testing is though there is a standard published, it's a new standard, so interpretation is a little different, the way it works is a little different, so we have to fine-tune certain things with the OEMs, and we do extensive lab testing as well as on-field testing, both with the OEMs as well as the utility partner out there. On the operational side of it, so the bidirectional needs are a little different than the unidirectional. So unidirectional, you just charge and leave it away. For the bidirectional requirements, you have to have a software integration with the utility. So utility is the one who is sending you the signals of when to discharge, right? And you need to be ready with the vehicle. You need to be ready with the full battery on the vehicle for you to completely discharge and get the benefit from the utility. It could be a ELRP programs, it could be VGI pilot from PG&E, so on and so forth. So what we have done with a lot of our projects is we have made it as a completely unmanned operations, meaning which that you can connect the vehicle to the charging station and just leave it away like that. So we have a mechanism where we can sleep, and wake up on the vehicle. So let's say, for example, you have a 4 p.m. to 8 p.m. A peak time, and you have a utility event during that point of time. So we'll schedule that, the software will schedule that point of time to wake up the vehicle and the charging station to start discharging, right? So all the times get connected, and that particular point of time, you'll wake up and start discharging. And we have all the controls inbuilt in the mechanism, inbuilt in the charging station as software that the vehicle should not go beyond 20%, right? So you can't discharge beyond 20% for battery chemistry reasons. And once that is done, so you keep connected still, right? So no one is going to come and unplug it. As soon as it goes to off-peak time frame, you will again start charging the vehicle all the way up to 100%, so that it's ready to serve the needs, may it be a school bus, may it be a refuse truck, may it be any kind of delivery vehicle. So you're ready for 100%, for the vehicle to go into the field next day. That's all I have, and feel free to come over to the booths. We're displaying the new launch I was talking about, the Nexus product, what we have, 600 kilowatts to 1.2 megawatts, different connectors and everything. So that's a new announcement, what we have done. So please feel free to come by and have a look at that.
If you have questions, feel free to come up to Sri after. I think that example of the having to keep the handshake between the bus and the charger alive to be ready for a discharge event, like that's the type of nuance that you don't necessarily hear about when you're getting a kind of standard V2G presentation, but that's the stuff that we're working through when it comes to actually deploying in the field, and how this promise of V2G revenue can actually be worked into the fleet operations without adding complexity for the fleet, because as soon as you add complexity for the fleet, they lose interest in this promise. So it's a really important issues. So yeah, with that, thanks for coming to our tour. I'll be back over at the TMH booth where we started. If you have any questions about any of our projects, please come talk to us. You can return your headsets with Sam in one of the tote bags. Yeah, thank you.
Good job, Sam.
Thank you.